Hi all, Dr. Clark here, and welcome to Animal Biology. Um, this lecture is just going to be kind of a brief introduction to Animal Biology, the course. Okay, so we're not really going to talk much about animal biology, but rather how to succeed in college level courses and what it means to kind of take a college course and succeed in that college course. So first of all, as you might expect from the title of animal biology, we're going to be dealing with animals in this course. And what a lot of people don't understand is what encompasses or what makes up the animal kingdom. We're talking about organisms from things like porifera, which are sponges, which have no tissues whatsoever and just a few types of cells, to insects, jellyfish, fish, snakes, amphibians, all kinds of things, all the way to what most people think of when they think of an animal, and that's actually a mammal, which is just a very small group of animals. Okay? And there's probably only 4,000 or so species of mammals on the planet, while things like fish, there might be 30,000 or more species of fish. Okay, and when we're talking about insects, I mean, just take beetles. There's about 250,000 different types of beetles alone. So when we talk about the animal kingdom and we talk about an animal, most people just typically think of mammals. And we'll talk about mammals in this course, but we got to gradually build up to that. And when I say gradually, what I'm talking about is we're going to look at animals from an evolutionary point of view. We're going to look at the most primitive animals. So we're talking about sponges and jellyfish and corals and hydra. And then we're going to move our way up and we're going to look at how over millions of years, sometimes hundreds of millions of years, how have organisms, in this case animals, how have they diversified and how have they become specialized for different environments? Okay, and we'll look at that. All right, so in this course, if you're taking it for credit, then you know that there are kind of three texts or three pieces of literature that are that are linked to the course, two of which I require, and that's the lab manual, animal biology lab manual that I wrote, okay? And you can purchase that through Western's bookstore. The book Your Inner Fish, which we use as a reader and you'll have quizzes on, and then a reference guide, Integrated Principles of Zoology, or any other zoology type textbook would work fine. It really makes no difference because you're going to be using this purely as a reference. Okay? All right, so in this course and all my courses, I often talk about two things that I require students to do and think that by doing this you have the potential to succeed in the course. And the first one is to take notes. I cannot advocate too much for taking notes, writing everything down. Okay? Individuals who write down things in like day-to-day life, whether that just be keeping a journal, writing down the mileage on your car, you know, writing down what chores you are going to do, writing down, maybe a TV show that you want to watch or a book that you want to read. Those kind of notes really help individuals keep track of their ideas. Right? And so taking notes in, say, a course will not only help you keep track of your ideas, things that you might need to study, things that you might have questions about, but it also helps you kind of compartmentalize the information that is being regurgitated to you. And so you can do this by taking notes on computers, handheld devices, pencil and paper, whatever it might be. So I highly suggest to students that they take notes, either handwritten, whatever it might be, on any lecture that I provide. Okay? All the readings that I, have that are required or might be optional. Any video that I might show, whether that be like a YouTube clip or a video that I show that's a scientific documentary, any of those are fair game for quizzes, exams, and just general knowledge. I mean, I'm not going to make you watch it if I don't think it's a valued resource. And the one that most people forget to do is take notes during labs. And so the labs are very intense in animal biology in that you're dissecting organisms, you're right down there with them, okay? You're examining things that you've never seen before. Most students have never seen a lot of these organisms, and you're cutting them open, getting to know the insides, the outsides, and things like that. And a lot of students forget to take notes on those laboratory procedures. And I can't emphasize it enough that notes for the lab is highly important. And most individuals who are taking an animal biology course have an interest in moving on in their career that's based on animal biology, whether that be a pharmacist, a medical doctor, a vet, a wildlife biologist. All these fields relate to animal biology, and having those good notes from a laboratory lecture, etc., will just benefit you in the long run. And the second piece is really about participation. Okay? Participation in lecture is really, not required by any means, but if you want the most out of a lecture or out of anything, you should participate in it. I've used this kind of analogy often. If you play sports or played sports when you were younger and you were on a team, well, that's great, you made the team. But if you never got to play, then you probably didn't like that sport very much. You probably thought, that sport was boring, or, you're very disappointed. Okay? But let's say you got to participate. Let's say you played, basketball or baseball or whatever, and you were part of the starting five, or, you're part of, the whatever it might be, whatever sport it might be, then you loved it. Most people. Okay? School is the same way. Courses are the same way. If you just sit back and just listen to the instructor and never interact, never ask a question, never, put your 2 cents in, then what are you getting? You're getting this, a bunch of information spit at you that you might be taking notes with, but you're not connecting the dots. You're not building your knowledge base, and we'll talk about that in a second. As far as labs go, it's required. Okay? Participation is required in the lab. You'll fail the lab if you do not participate. So that would include participation in dissections or experiments and these kind of things. That's required. And that's one way, laboratory setting is one way that we, as scientists, we often take the information that we're giving to you during lectures, and then we're giving you a chance to apply it to try to build the knowledge that you need to succeed in whatever avenue, whatever career path you choose in the future. So participation, I mean, it's not that I need you to see you jumping out of your seat during class to answer questions or ask questions or something like that, but excitement when you're excited would be great. I mean, the more joy you have in a course, the more excitement you have in a course, or really anything, the more likely you are to retain the information that you're learning or supposed to be learning in that course. Okay, I say this to all my students. This course and all courses that I teach will probably provide you with a lot of information that you've never heard before. Some of that information might contradict what you've been told or what you might believe. Um, and I assure you, unless you can find elsewhere, that I am giving you the facts. I'm giving you what scientists would call the truth based on the facts. Um, and so I always say the truth will set you free, but first it might piss you off. Okay, so sometimes things will be stated in lectures, the lectures that go on to YouTube or lectures that are given in class, labs, etc., that you just don't agree with. And in many cases, by you not agreeing, you're probably denying the scientific facts. Okay? And that's your right. No one can take that away from you. However, in a scientific point of view and from a scientific community, denying facts means that you're not being a very good scientist. Yeah? So we can take that example and run with it. So we can talk about like the average American is 15 pounds overweight. So let's say you want to lose weight because you're going on a trip in December to Hawaii, okay, and you want a beach body, okay, and so maybe we're talking you got 3 months to lose it. Maybe you need have more, but let's say you have 3 months to lose that weight. So if you work out every day for 3 months, you'll probably lose the 15 pounds. Okay, I mean, probably. Okay, now each individual is different, but probably lose the 15 pounds. If you work out 3 times per week for 3 months, maybe you won't lose the 15, but you'll lose 10. Okay? If you work out 1 month before you go every single day, maybe you only get that 5 pounds. Okay? Studying is the exact same process as working out. If you study every single day for animal biology or statistics or mathematics or whatever, chemistry, it doesn't really matter what the field is. Right? If you study every day and you put the work in to learn the material, then you're most likely going to earn an A. Right? If you're only studying 3 times a week, you're still above average. You still study way more than the average individual does. So you're getting a B, which is above average. C's are average. If you study the day before the quiz or day before the exam or maybe even a couple days before the exam, etc., you're probably going to earn a C, okay? Which is average. Okay? But most individuals that are taking something like an animal biology course, you're not after a C. A C is not going to do it for you because there's a lot of competition into getting into med schools and vet schools and pharmacy schools and things like that. And GPA matters. Right? So, a is probably what you want, and you have to, if you're going to strive for that, you have to put the work in. Just like if you want to lose the 15 pounds, you're going to have to put the work in. Okay? So I also like to point out to students, because sometimes students don't think about this very much, but it's not just how much you study, but it's how you study. Okay? So if you're studying with the TV on or music or studying with your friends or studying with your phone and Facebook app on or you're cramming for things, maybe you're not studying correctly. Or if you're studying, multiple subjects at the same time, studying late into the evening, these kind of things, maybe it's not enough. And maybe it's not about how much you study, but actually how you study. You're studying or you're going about it all wrong. Okay? So I always like to talk about this kind of cycle, this kind of piece, mainly because I had a professor that would often talk about the differences between being an undergrad, a graduate student, and then being a professor. And he divvied it up like this. He said, undergrads are getting information. Graduate students are gaining knowledge, and professors are gaining wisdom. Okay? And so what, I took that, and then I've always used that, and then I often would say, well, what does it mean to today's generation? Okay? Well, I mean, this is a good kind of analogy. Okay? Information is free. Okay? I mean, every single person, not every single person on the planet, but I think to this point now, I think almost half the world's population, so about 3.5 billion people or so, maybe even a little more than that, have now got internet service, so they can actually connect to the internet, which means that information for them is free. And often it's good information. Sometimes it's not so good information, but it's free information. Okay? And so if I ask you for the definition of something, like what is a cnidarian, okay, you could Google that and give you an answer. Okay? And that's information. Okay? Now, part of that is in courses just like animal biology, there is going to be a piece of that course where you need to take that information and you need to subject that to your memory. So you need to memorize it in some way. Okay? And what you're going to be memorizing is facts. Okay? Facts that scientists agree on. Okay? That's the information piece. And that's enough maybe in, say, general classes. That might get you, in some general classes, that might even get you an A. Okay? Being able to do that. But knowledge is taking those facts, taking that information, and combining it with your skills. So using your skills to combine information so you can apply that information. You can apply that, and that's how you gain knowledge. Okay? And so knowledge is often considered theoretical and practical understanding of certain subjects. Okay? So in this course, we're really going to concentrate on doing that, taking the information given to you, and then applying that information to gain knowledge. And so it looks something like this. Information could be represented as just dots. Knowledge is represented as connecting those dots. And then once you have enough of this, you could develop wisdom, which would mean that maybe you are looking at this and you know enough about it that you know that only two dots matter. Or for that matter, you know that two dots connect everything. Or maybe these are the two dots that you could remove and not change anything. And so that is the development of wisdom, is knowing your subject material so much and so well that you can manipulate it without altering it, or maybe you can manipulate it and know what the outcome is going to be. Okay? And that's going from information, just general facts, to application of those facts, okay, to manipulation of those applications and those facts. I think Einstein probably said it best. Information is not knowledge. Okay? The only source of knowledge is experience. So in this course, how are we going to get experience? We're going to get experience in three main ways. First, you're going to dissect. Okay? You're going to do a large number of dissections. Okay? I believe if we talk about the organism in lecture, or at least the group of organisms in lecture, you should dissect that organism. If I'm talking about livers and kidneys, and if I'm talking about phylloic spica and cecum and these other things, then you should probably see them. You should probably know what those structures look like, and not what those structures look like in a picture or in a digital program, but what those structures look like because you have dissected the organism and examined it. Okay? So that's where dissection comes in. We'll talk a lot more about respecting organisms. Okay? The organisms that we dissect in this course are organisms that are used in dissection across the nation. Okay? They come from companies that respect organisms, companies that obtain these organisms legally, either by raising them themselves or obtaining them as byproducts of, fish catching from the fisheries industry, byproducts of euthanization from animal, like animal, uh, how do you say it? Like animal welfare kind of euthanization. So like cats coming from euthanization from the pounds and things like that. That's where they obtain these organisms. It's not stealing individuals' pets, um, nothing like that. These are not wild caught endangered species that we're dissecting. We're dissecting organisms that um, are used for scientific purposes. Okay, so the dissection is a big piece. Okay? Research is another big piece. You will design and implement your own research project. Okay? And by doing so, you're going to go from obtaining the information, applying the information, okay, gaining the data, etc., and then examining the outcome. So you're going from that information gathering to the knowledge. What does it mean if these two data points are different or the same? Okay? That is where the research comes in. And then just general testing both your capability of memorization and your capability of applying memorization to more advanced questions come in play when we talk about quizzes and exams. Okay? And so as much as I think the digital realm and the digital era of digital dissection, etc., has become much more advanced than what it was when I was taking animal biology, I still think that there is nothing that can replace the actual hands-on dissection capabilities. No one wants a doctor that goes through all of their schooling with digital programs and using a mouse to do the dissection, okay? A computer mouse that being, okay, to do the dissection and then be their first patient on the table when they actually need to do a dissection. Okay? Med schools aren't going to do that, okay? At least not in the foreseeable future. Now, they might be replaced by robots to do the dissection, but okay, humans won't be doing digital dissection in med school, and until they tell me I can't do it any longer in animal, we will be dissecting organisms, not virtual organisms, but the actual preserved specimen. Okay? And so with that, that's kind of the overview of animal biology, and you'll see a bunch of lectures, and you'll see the all the organisms that we dissect in this course. You will see them dissected on video, and those will be in the lab section. So you can watch the dissection before you perform the dissection, and if you're just watching this to obtain knowledge, then you can watch the dissections and gain the knowledge without ever getting your hands dirty, to say. Okay? All right, till next time.